Today we're going to talk a little bit about nuclear weapons or weapons of mass destruction that are man-made and the different processes that go along with each one, such as nuclear fission or nuclear fusion. We could see these weapons that have been used in history, such as the hydrogen bombs that were used to bomb the cities of Hiroshima and Nagasaki in the 1940s. But to begin, we'll talk a little bit about atomic bombs. Atomic bombs work by using the process of nuclear fission, which is when heavy nuclei atoms split apart and release neutrons, which sets off a nuclear chain reaction and radioactive decay occurs. The process in which these bombs are ignited we have a torpedo missile shape with a rounded head, which contains a core of concentrated mass of fissile material. Usually it's uranium-235 or plutonium-239. Plutonium-239 is artificial and man-made, and it's a lot harder to come by. So uranium-235 is the isotope typically used. It has to be around 80% or higher to be effective, which you could use other isotopes of uranium, such as uranium-238 or uranium-234, which could be, through man-made processes, spun in a centrifuge to help create a higher concentration of the uranium-235 isotope. But we have the fissile material that's concentrated within the core of the missile, and it needs to be ignited to reach a critical mass. Usually one critical mass is not enough to set off the chain reaction of nuclear decay. So we'll see there's typically 4 to 5 different masses of concentrated heavy atomic nuclei. And the most common way for this nuclear fission reaction to take place is through a guided explosion, and it's called an implosive explosion, in which case there's explosive material on the outside that explodes, and in that process it causes these masses of heavy atomic elements to condense and collide with each other, which will successfully set off the nuclear chain reaction that is what they are attaining for with a nuclear bomb, such as the atomic bomb. Now to move over to a nuclear fusion reaction, as we could see in hydrogen bombs, we could pretty much talk about the bomb itself and the reactions that occur within the bomb. So it's shaped essentially the same way as an atomic bomb, but the inside is a little bit different. It begins like an atomic bomb in the sense that there's an integrated nuclear device, which is a low power device that is used to initiate nuclear fission. Typically, deuterium and tritium are the heavy elements used, along with lithium hydride, to create this small fission explosion that, again, it compresses those heavy elements inward to release the atomic nuclei chain reaction. And in that case, X-rays are then emitted, which are very high power throughout the internals of the bomb, which bounce off the internal casing and create a heat foam plasma that essentially ignites the spark plug of the secondary core, which contains the fusion fuel, which then sets off the nuclear fusion, thermonuclear reaction, and the entire hydrogen bomb detonates. And it's a very large and devastating explosion. When it comes to measuring the explosion of nuclear weapons, we like to use something called TNT equivalence. So pretty much we have this one hydrogen bomb and it explodes. How many pounds, typically it's used in pounds, of TNT are used to create an equivalent explosion? its TNT equivalent is measured in kilotons or megatons to determine, okay, this hydrogen bomb is worth the same as 58.6 megatons of TNT. So after these bombs explode and you see the explosive damage that could tear apart an entire city, you also have to look at the aftermath of the explosion. These nuclear radioactive weapons release radiation in the forms of alpha, beta, and gamma radiation. Alpha waves are typically not damaging, but beta waves will burn skin, burn eyes, give you cataracts, and are definitely very dangerous. Gamma radiation is the most dangerous, damages human and any living thing's DNA, causes radiation sickness, and causes cancer because it mutates your DNA. Right now, there's approximately 9 countries that have access to nuclear weapons, which totals out to be about 15,000 different types of thermonuclear or atomic weapons total. In that case, it's still 13,000 times less destructive and powerful as the asteroid Chicxulub, which would completely wipe out and destroy Earth. But I appreciate you guys watching and learning more about nuclear reactions and how fission reactions and nuclear fusion reactions work. Thanks for watching.